So it's IGCSE Edexcel. Basically, it's paper 1C. Or this is question number one. Which of these is a correct symbol of an element?
H
Element, they are saying.
H2.
H2
Oh
for an
wait, no.
element.
Oh, an element is He.
Exactly, it's helium, right? It's helium. Element, what's the definition of an element? Obviously, it contains the same type of atoms, right? It
Yeah.
contains the same type of atoms. So, which of these substances is a compound? We have air, hydrogen, oxygen, and water. So,
Uh, what's
hydrogen is H2, oxygen is O2, water is H2O, air is a mixture of different gases.
which
So,
is
A is not correct. It would be D, right?
yeah. I said the water. Yeah.
Yes, hydrogen and oxygens are molecule. Which of these methods is used to obtain water from a mixture containing salt and water?
So
So,
I think it's is it filtration
uh,
or
which
simple
of these
distillation?
methods is used to obtain water from a mixture containing salt and water? The salt is soluble in water. So if the salt is soluble in water, so filtration is not possible. Filtration we can do when the salt is insoluble in water. Okay.
Crystallization.
So it should be crystallization. Exactly. Okay. Four known inks A, B, C, and D are also spotted onto the same paper. The diagram shows how the experiment is set up and the paper at the end of the experiment and the paper at the end of the experiment state why the solvent level should not be above the baseline at the start of the experiment.
Why the solvent level shouldn't be above the baseline. Uh, to ensure. Wait. 1 second. Because then it will, if the solvent is above the baseline, then it will react with the ink, and then it will like smudge kind of. It'll smudge the, and it won't. You won't get accurate reading because it'll smudge the ink, I guess.
Yes, if they are saying that like baseline at the start of the experiment, this is your baseline. The baseline is just above the solvent. This is your solvent. This is your solvent, and this baseline is just above the solvent.
Yeah.
So on the baseline, we have some spots of the sample.
Yeah.
So if your baseline is not above the solvent, so your sample would dissolve into the solvent. So
Yeah.
if this is dissolved in a solvent, so how can you separate the, you can say, how can you separate the sample? So
Mhm.
to prevent, to prevent the spot, to prevent the spot mixing, mixing in the solvent. So the baseline should be just above the solvent. Explain which dye present in one of the inks, A, B, C, or D, is also present in ink P. At the beginning, it was this. After doing chromatography, we did this. We got this. So they
Okay.
are saying this is your ink P. This is your ink P. So we have four samples, A, B, C, and D. He's asking which dye, A, B, C, and D, which dye present in one of the inks.
Oh, it's also an ink P. Okay, let me. Can you go back up?
Hmm.
It is B because um the second ink for is ink P. The highest one is also at the same level as the ink in P. B. I mean.
Yes. This is the first one. This is another one. This is another one. This is another one. As you can see that they are at the same height. They are at the same height. But they are also at the same height, but the base thing is your sample, that is P. This is standard. We are going to compare anything from this P. So that's why I have to see that option in which the P is involved. So that is one and only. I'm supposed to write that your B is Your B is there in your ink P because the RF value is same, because the peak height is same, or you can say because the distance of that spot and this spot is the same from the baseline. If the distance is the same, so means they are the same. So B is present in the ink. So I am supposed to write B, spot B covered the same distance as P. So P contains B. Why ink D does not move during the experiment? You can see D, it has not moved. Why? Everyone has moved. A moved to that point, then this is your B, this is your C again, but D is not going to move anywhere. What's the reason?
D doesn't move as it's insoluble, I guess.
Yes, when something is insoluble in the solvent, so it's not going to move. Okay, all
Okay.
the inks are soluble in water, soluble in the solvent, so that's why they are going to move along with water, along with the solvent. It may be water, it may be any other solvent. So when the substance D, when the substance D is not moving, so means that uh, like ink D is insoluble, insoluble in water. Okay, now say this. Complete the table for dye. For the dye in ink A, distance moved by the dye in ink A in millimeter. In millimeter. So, in A. So, what you would be doing, say this, you'll be taking your ruler and you are supposed to put your ruler over there, okay, at the baseline, exact, it's going to match, and then you are going to measure the distance from the baseline, that is this. Okay, I'm going to measure the distance. Approximately it's 2. Approximately is it's they are saying in millimeters, right?
Yeah.
They're saying in millimeters. Oh my god, it's not. Okay, this is 0. This is 0, and yes, you can see this. This is the this is your baseline, and approximately in millimeters if I'm going to count. So this is 10, this is 20, then this is 30, then this is 40, then this is 50. 50. So ultimately the answer is approximately 20. The answer is 20. If you can see over there, these are the millimeters. Okay, this is the millimeter. So this is 10 and this is 20. So approximately the answer is 20. I would write that the answer is 20 basically. And
Okay.
then RF value. RF value. They have given you the distance of the solvent, that is 49. They have given you the distance of the solvent, that is 49. You know what's the formula for RF value? You know what's the formula for RF value? RF is equal to the distance of solute divided by the distance of solvent. Okay, RF is equal to the distance of solute divided by the distance of solvent. So
Yeah.
the distance of solute is given to you, that is 20, and the distance of solvent is also given to you, that is 49. So can you divide it?
20 over 49. It's 0.4. It's 0.4.
0.4. 0.4. Yes, that's your answer.
Okay.
The diagram shows an experiment to demonstrate diffusion. Cotton wool soaked in concentrated ammonia solution. Like basically, this is NH3 solution, and cotton wool soaked in concentrated hydrochloric acid, that is HCl. Okay. So the word equation for the reaction that occurs in the experiment is ammonia. It's going to react with hydrogen chloride. It's going to form ammonium chloride. So the formula would be NH4Cl. It's balanced equation. Draw a circle around each of the two state symbols that could be included in the chemical equation in part E, part 1. So, what is the solid? What is the liquid? What is aqueous? Who is the gas? What do you think? From
Okay.
where I'm supposed to attach these say, symbols?
Draw a circle around each of the two state symbols that could be included in the chemical equation. So HCl is a liquid, but it's so okay. NH4Cl is aqueous. Um, is HCl aqueous or liquid?
HCl is aqueous. Aqueous. This is an acid. Acids are aqueous in nature.
And then ammonia is gas, right? So that would be gas, aqueous, and then overall it will become liquid, right?
Okay.
Ammonium chloride is liquid, right?
So, this is aqueous, this is solid. There is no liquid in this. There is no liquid in this. So,
Oh,
I would be drawing a circle over, over S. Only the solid is there, and also a gas is there.
gas,
You
yeah,
know, you
H3.
know, this is the, oh, they have written HCl, hydrochloric acid. But this is your ammonia as well. Okay, this is your ammonia as well. So when they are going to diffuse, so they would be diffusing in the form of vapors, in the form of gas. So the gas and the solid is there, but there is no liquid and there is no aqueous basically.
I said gas at the start,
Yeah,
but
yeah,
yeah,
yeah. Okay, okay. Complete the diagram. It's very easy. Obviously, you would be drawing the circle. They are tightly packed together, just like that. Okay, they are tightly packed together.
yeah,
So, as a reference, you can draw 5 to 6 circles.
yeah.
Okay, then which row of the table correctly describes the arrangement and the movement of molecules of water in the solid state? So, in the solid state, obviously the arrangement is regular, not random. Not random. Okay, in solid state they are saying. So it may be A, it may be C, but movement in solid state, what about the movement? So
See,
they are
not
going to vibrate. They are going to vibrate. So that's why C is correct.
yeah.
That's why C is correct. Which word describes water changing from a liquid to a solid? Liquid to solid, basically.
It's freezing.
It's freezing, exactly. And water is the name used for H2O liquid. Give the two names used for H2O gas.
Water vapor
Exactly.
and what else? Water vapor and
Or
or steam. Yeah,
I can say steam, right? I can say steam.
yeah.
Okay. Okay. Then uh, balance the chemical equations for these reactions. CH4 is going to react with oxygen and it's going to form carbon dioxide and water. And then C2H4 is going to form, you can say, it's going to react with oxygen. It's going to form carbon monoxide and water, basically.
Yeah.
So how can we balance this equation? The number of carbons are equal to carbon dioxide and the number of hydrogens and the water. You can say that it's exactly half. I mean to say
Like we have four hydrogens in the reactant side, so I am supposed to write two over there because carbon carbon is balanced. We have one carbon and one carbon. After writing two in front of water, so how many oxygens you would be having? You will say this is two and this is two, one's a two. So the total is four. So in the product side, I have four oxygen atoms. So to balance this oxygen, I need to write two over there. So they would be balanced. So
Okay.
that equation would be balanced. How
Okay.
can you balance the second equation?
C2H4. Okay. So if we have one carbon on the other side, and there's two there, so we need to add a two in front of the CO. Add a two in front of the CO,
Okay,
and
good.
then after that we have two oxygens, two carbons, and then we need to add another two there. So that means now we have four hydrogens, three oxygens. We need to add a. We need to. Oh wait. Do we need to add another two in front of the oxygen there? Because we have four oxygens on one side and only two on the other side. So we need to add another two.
This is two.
Yeah.
Okay, it's easy. Okay, then see this.
Explain why two letters represent neutral atoms of the same element. Um, two elements represent two neutral atoms of the same. Not really sure to be honest.
Wo
Oh, the isotopes. Isotopes.
letters represent neutral atoms of the same element. Of the same element.
Does that mean isotopes?
So isotopes.
Does that mean isotope? Does it mean neutral atoms? What do they neutral atoms mean?
It's of 3 marks. It's of 3 marks basically.
I'm not really sure to be honest.
Uh, if you can see A and B, in which you can see the same number of protons, same number of electrons, but different number of neutrons. Same number of protons, same number of electrons, but different number of neutrons. Okay.
Yeah.
So we can say that they are like neutral atoms because they have the same number of protons and they have the same number of electrons. That's the reason they would be canceling each other. So as a result, I can say this is neutral. Okay.
Yeah.
And they are called isotopes basically. So the question was, explain which two letters represent neutral atoms of the same element. I would say that A and B, A and B have the same number of electron and proton. They would cancel each other. As a result, I can say this is neutral.
Okay.
Which two letters represent negative ions formed from the same element? Formed from the same element, negative ions. How can you identify which element is negative, which ion is negative? Yes?
Um, ex- how would we explain which two ions cancel out?
No, negative means they have the same, they have more electrons than protons. Negative means they have more electrons than protons, okay? And
Yes.
positive means they have more protons than electrons,
Yeah.
right?
Yeah.
Yes. So obviously, if you can see, uh, uh, GNH, they have more electrons than protons. They have more electrons than protons, GNH. So ultimately, they would be forming a negative ions as they have more electrons than protons. So the G answer would be GNH as they have more electrons than protons. Okay, this is of 3 marks. Oh
Yes.
my god. Okay, what is the electronic configuration of species E? Yes, E.
It would be two. It would be 2 and 5.
So how did you identify that the configuration is 2 and 5?
The number of electrons on the first shell is 2. The next
Yes.
one
So
is 8.
in E, you can see that it has the proton number is 7. So obviously, 7 means that in the first shell we have 2 electrons, and in the second shell we have 5 electrons. So the overall electrons are 7. So that's called electronic. You know what's the definition of electronic configuration and what we do in electronic configuration? It's the arrangement of electrons in different shells. It's the arrangement of electrons in different shells. Okay. So that's why the configuration is 2 like and 5. Okay.
Okay.
Or the table shows the percentage composition of a sample of magnesium. Calculate the relative atomic mass of magnesium. The relative atomic mass of magnesium. So how you would be doing this question?
Relative atomic mass. To find
Hmm.
the atomic mass, you need to do. You need to add the wait. The this. Uh, Add all the percentage of isotopes, then divide it by 100.
Hmm?
Do I add all the percentages of isotopes and then divide it by 100?
Yes. Yes.
Oh, so 78.6 plus 10.1 plus 11.3. It's 100. Then what do I divide it by?
Hmm.
What should I divide it by?
So, you know what you are doing for this. The formula is isotopic mass. The formula is isotopic mass multiplied by abundance. The formula is isotopic mass multiplied by abundance. Like I mean to say, it would be 24 times this, 25 times this, and 26 times 11.3, and then divided by 100.
Okay,
Whenever you see this question, so you are supposed to multiply the isotopic mass by the by the like the percent abundance. So the masses are given to you that are 24, 25, 26, and the percentages are as following 78.6 and onwards. So
okay,
I would be multiplying the isotopic mass with the percent abundance. Then I would be adding them together to get the final relative atomic mass of magnesium. That's the method, okay?
okay, sure.
Yes. What's the answer?
Oh, let me check. One sec. 24 times 78.6. Then that number add add brackets 10.1 times 25. And after that, add what's the next number? It's 11.3 times 26. 26. All that number divided by 100. It is 24.3.
24.3. Okay.
Yeah.
So this is 24.3.
Mm-hmm.
See this?
What numbers are used to identify the period shown in this diagram? Um, the numbers, periods,
What numbers are used to identify the periods shown in the diagram?
um,
Obviously, the number of shells. Am I
yeah,
right?
yeah,
So if you have two shells in total, means that it's in second period. If you can see four shells in total in any element, so you can say it's in fourth period. And also we can identify the group number by just looking at the number of electrons in their outer shell. So explain which element in the diagram is the least reactive. It's half of the periodic table, I think, so it's cut off.
it would
But
be
obviously, I can identify by looking at the periodic table that which is the least reactive. Ultimately, the least reactive ones are
A,
in the extreme right of the periodic table. Am I right? Extreme right.
yeah, or
Extreme
other,
right means they are noble gases. They do not react with anything else. They have a complete outer shell. You know, uh, I saw a question in which this examiner was asking that why noble gases are unreactive, why they are inert. So, most of the students wrote that they have eight electrons in their outer shell.
yeah.
No, this is wrong. This is wrong.
It has a
Why?
outer shell
Because
because hydrogen or helium only has
helium, exactly. Helium cannot have
8 electrons.
eight electrons. That's why. So you are supposed to write they have complete outer shell rather than saying that they have like eight electrons.
Yeah,
Okay.
yeah.
Yes. So in short, argon is the least reactive, as we can see in the right hand side of the periodic table, as it has complete outer shell.
Okay.
State the similarity in the electronic configurations of sodium and argon. What's the similarity?
Um, they're both in the same period, meaning that the both amount of shells, the same amount of shells.
Exactly. They are in the same period. They are in the same period. That is, I think so, they are in the third period. They
Yeah,
are in the third period. So they both have the same number of shells, which are three. Sodium has a proton number that is 11. So when I would be writing electronic configuration, so I would be writing 2, comma 8, comma 1, as this is 11. So 2, comma 8, comma 1. In the first shell, we have 2. In the second shell, we have 8. In the third shell, I have 1. So when I'm going to draw the electronic configuration of neon is, I think so, it's uh like what's the proton number of neon?
proton number of neon.
It's 10, I think so. It's
Yeah.
10. So 10 means that it's 2 comma 8.
Yes,
It's 2 comma 8.
yes.
So
It is.
they
It
do
is
not
10.
have the same number of shells. They do not have the same number of shells. So how can I say state the similarity in the electronic configurations of sodium and argon? Yes.
Um,
Hmm.
they
It's
are
good.
in, they are in the same period though.
No, they are not in the same period. Otherwise, they would be having the same number of shells.
The electronic configuration of argon has 3 shells, and sodium also has 3 shells.
No, man, you can see sodium is 11 in the first two, in the second 8, in the third 1. Sodium has 3 shells. How can you say that this neon has 3 shells? since the proton number is only 10. In the first shell, I would write 2. In the second, I would write 8.
It says argon.
That's it.
It says argon, not
It's
neon.
argon?
Look, it's
Oh, okay. It's argon.
it's not neon.
Oh my God. Okay. Yes, argon is 18. Okay, 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 okay. Okay. And state the similarity in sodium and rubidium. Sodium and rubidium. Sodium is 11. Sodium is in the third period. And rubidium is in the fifth period.
But
Rubidium is in the fifth period. Exactly. So rubidium would be having. So,
one
so
electron.
again, they are asking the similarity. They both have one electron in it in their outer shell, right?
Oh yeah.
So state a physical property of sodium that shows it's a metal.
It's shiny on the outside,
Or
shiny on the inside. I mean, or soft.
soft.
Yeah, it is. Sodium is soft, but that's not a property of a metal. It is. It's shiny. There you go. Is that not one property? Physical.
Yeah. So you can say it's a good conductor of electricity. Okay. It's
But
a
it says
good conductor of electricity. It's a good conductor of heat.
yeah.
Or, okay. So, yes, they are ductile, they are malleable, but you're not supposed to say they are shiny. You're
Okay.
not supposed to say that they are shiny. Okay. You can write any other physical property.
Okay.
Hmm.
Sure. When we're done the class, can you send me some other questions to do?
Yes. Yeah. See this? Complete the word equations for the reactions that occur. What you would be writing in this?
So word equations would be magnesium plus sulfuric acid would be magnesium sulfite or sulfate. I think it's sulfate. Magnesium sulfate.
Okay.
And then copper oxide plus hydrogen will be
Only magnesium sulfate. Any other product?
no.
And hydrogen gas.
Oh, and hydrogen gas, yes.
Whenever the metal is going to react with any acid, they would be producing hydrogen gas as well, right? So
Yeah.
in the first, I can write hydrogen gas and also the magnesium sulfate. And what about the second one?
Copper oxide plus hydrogen. Copper oxide plus hydrogen would be copper hydroxide. Copper hydroxide, right?
Copper hydroxide. It would be copper and water basically. It
Oh,
would be copper and water.
oh
You
yeah,
know, the oxygen of copper oxide would be reacting with the
hydrogen.
oxygen of copper would be reacting with copper oxide would be reacting with hydrogen and it would be forming water, leaving behind copper metal. Leaving behind copper metal basically. Okay? Yes. And you have anhydrous copper sulfate. What do you think about it? Anhydrous copper sulfate. So what you would be writing in this? Anhydrous copper sulfate.
I'm not sure what anhydrous means.
Anhydrous means there is no water. Anhydrous means there is no water in it. Okay.
Copper,
So ultimately,
copper sulfide? Sulfide, I think then. Copper sulfide.
when in anhydrous copper sulfate, you are going to add water, it would becoming hydrated copper sulfate. Remember, I'm repeating, when in anhydrous copper sulfate, you are going to add water, it would becoming hydrated copper sulfate. Hydrated means now this copper sulfate is surrounded by water molecule.
Okay.
Okay, yes. Rest of the topics you, I think so you haven't done.
Yeah, we
Okay.
have it.
Yeah. Okay. So we have a lot of questions uh, about that topics that you did so far. So I'm going to share in the group as well. Okay.
Okay, thank you, sir.